Just for fun, I went ahead and torqued the main caps on with the original hardware, and I want to check the size on the main bearing bores here, and then we'll go ahead and put in our ARP studs and see if it changes much. We're going to line hone it regardless, just because we want it as good as we can make it be. But I was just curious. They always say when you put studs in, you need to do a line hone on it, and I want to see if it really does change much from what it is with just the original hardware.
Yeah.
So anyway, I've set the bore gauge up to 0 is the middle of specification, and we'll go in here to the middle one here and check it there, and we're just a little bit past the middle of spec. When I go side to side, try to get some readings, it looks like it's pretty round, but it is just a little bit on the big side. This one, same thing, it's just a little bit big. This back main is actually out of spec. It's about a half a thousandths too big.
And that's with a dummy oil pump.
Yeah, that's with
torqued
I've
on.
cut off an old oil pump there and torqued that piece on to simulate a pump being on there. Turn this around where I can reach the front mains here. And very front one, it's kind of right on the loose side of spec. That one's probably 3/4 of a thousandths egg-shaped and a little bit on the big side. But in reality, if this was just going to be a stock engine, there's probably nothing wrong with those. I think this would run a long, long time just the way it is without doing anything special to it. But with as hard as this engine is going to get run, we want to make sure everything's as good as we can get it. So we've gone through, we've put in our ARP main studs, and they are all torqued as per spec. And we're going to check these again. Things haven't changed a whole lot. I've got about half thousandths loose on that side. I come to the back. Yeah, I'm ranging right at half thousandths looser than spec. We come into these, I'm right in the middle of spec, a little on the tight side. If anything, if there's any distortion here at all from putting those studs in, it is actually that it's just tightened it up just a little bit. There's a thousandths leeway, and I set 0 right in the middle of what the spec was. So if we're anywhere in the green, it is fine. There's no reason to worry about it as long as we're in the green. But again, if we want to make it as perfect as we can, we're going to go ahead and do the line hone on it. Yeah, we're right in the middle of spec there. Where we're at right now, is it perfect? No. Is it in spec? Yes. So I guess it all boils down to what degree of perfectness, is that a word?
Perfection.
Perfection. How good do you want this to be?
Okay, so we're going to send this out.
Yeah, we'll get it over to our line hone guy this afternoon and see if he can work his magic on it.
You want to walk through the after getting it line honed?
Yeah, so we got sent block out to another shop that has line hone. So I'm quite pleased with the way it came back here. I've got our gauge set up here, so 0 is the middle of spec, and this is coming in just a little bit on the tighter side of middle of spec.
Well, and when you're talking tenths,
that's not very much.
when we're talking tenths, different in temperature between our shop and his shop, different in the way you set your bore gauge versus his. When you get down to tenths, there's a lot of
variation here, and I'm just quite pleased that it has come in the way it is. I think he did a real nice job for us. You know, when we started, this main cap here was a good thousandths outside of spec, and he's done a good job bringing these in and making them round. Every one of them is coming up just slightly tighter than the middle of spec. We'll pull the main caps off here, and I'll show you some of the things he did to be able to make that come in the way it did. So the way that a line hone is done, you have to figure out a way to cut this cap to make that hole through there smaller so you can hone it back to standard size again. And the way that's done is just like when we do connecting rods. This mating surface is put in the cap grinder and is ground Our machine is not set up exactly for main caps, but there's just a small amount, just a few thousandths taken off the face of the cap so that when it's put back on the block and torqued on, it'll be smaller. And then you go in with the line hone and hone it back to standard size. But one of the things I do run into when you're putting studs in, if you'll look here, I've got an original bolt and I've got one of the studs that will be going back in. And you can see the original bolt necks down a little bit smaller through the center there. That's smaller than the threads or the very top here. Stud is the same diameter all the way through. And what happens is when you put the cap on, there's not enough clearance through the hole in the cap, and sometimes that'll push the cap one side or the other so it doesn't sit down in and mate up in the register here the way it should. So on this particular motor, he told me when he did the work on this, I didn't catch exactly what size he went, but he did drill all of the main cap holes just a little bit larger so that when it's on the block, you have a little bit of wiggle room in the studs themselves so it doesn't distort the cap when it sits down into the registers on each side here, because this is where you want it to locate from, not from the studs themselves. Basically, we got a good start going on this motor, so I think we're ready now. We'll move over so that we can deck the block, and we're going to see if we can deck this thing down to within about 5 thousandths of zero clearance deck height on the piston.
Just real quick to let everyone know, there's only 1 week left to order our limited edition custom mousepad in collaboration with Epic Desk. Inspired by the 4-stroke internal combustion engine, suck, squeeze, bang, and blow, this mousepad measures 930 by 400 millimeters, or roughly 36.5 by 15 3/4 inches. This is a custom commissioned piece of artwork in collaboration with our machine shop, and it's only available on pre-order until August 13th. After that, they'll never be available again. So be sure to pick one up for your desk, and maybe even pick up the 2-piece bundle to have one as a work mat for those delicate parts in your projects. Check out the link in the description for more information, and don't miss out on this one-time run. We decided that, and this is actually still the dished piston. Everybody kind of...
Right, we're going to end up using a flat top piston in it. Everybody convinced our customer they needed 10.5 to 1 compression. So,
okay, pistons aren't coming until next Monday, but the compression height is the same on this piston,
right.
And for reference for the video, it is what it is. We decided we are going to put our piston 5 thousandths in the hole as opposed to perfectly zero decked.
well, 5 thousandths is not going to make that much difference on the quench, and it allows a little bit for machining tolerances. We know what all this stuff is supposed to be, and I'm sure it's all very, very close to that. Everything we've checked has been very close, but you can have machining tolerances stack up and get you in trouble. So we like to stay 5 thousandths in the hole just as a little buffer there for us. And then someday down the road, if this motor gets built again and somebody wants to deck the block to clean up a gasket surface, there's still 5 thousandths to work with.
Yeah. So basically we have to do a little bit of math, but we're going off of the numbers that are listed. So the numbers we're using are the 5.7 inch center to center distance of the connecting rod, the 1.425 pin height. So that's from the center line of the piston pin to the top of the, in this case, flat top. Stroke length of the crankshaft, actually half the stroke length for the way we end up setting it up. But yeah, so 3.750 on the stroke length. We only need half the stroke length because you're calculating from the center line of the main bore to the center line of this rod journal when the rod is at top dead center.
Right.
There's a lot of different places in there where your tolerances can stack up. The rod could be just a little bit long, pin height could be a little bit short, stroke length could be a little bit short, a little bit long. That's kind of where we give 5 thousandths for tolerance there. We have a gauge here that we can use to measure our deck height. To do our math for what we need to set this gauge to, we take half of our stroke length, 1.875, our connecting rod center to center at 5.7 inches, our pin height at 1.425 inches, and then we need to subtract half of our main housing because when we're using this gauge, you'll see later, we're not actually measuring at the center of the main bore, we're measuring at the top. Then we need to add back our depth that we want to stay in the hole, 5 thousandths, and what we want to be reading on this gauge is 7.684 inches.
Right.
That should be the distance from our final deck surface to basically the top side of that main bore.
Which in reality to the center line be 9.005 inch.
Yes.
Isn't that correct?
Yep.
Well, what this amounts to is it is just a fancy little fixture here to hold the dial indicator so that we can indicate off of the housing bore, main bearing housing bore, and to the deck of the block. So the way we set that is we start out with one of these standards. This one, for instance, is 8-inch standard. And you'll have to excuse me, I shake a little bit. It's kind of hard to get these set up. But I want to set this up. You can do it numerous ways, but I always like to have it to where when I have that block where it needs to be, I'm at 0 on the gauge. Come out at 0 on there at our 7.684. Taking that from 8-inch, 316 thousandths. So I'm going to put this in here. There it is, 316.
Yeah.
Right there. Let me go over here on the block with this. Let's go down through a hole here.
You can see that the bottom of that fixture is referencing off of that main journal. The top of the indicator is right there on the deck surface.
And as you see, as I move side to side here, it brings that needle up. So I have to keep moving around here, and I find the point it reads the lowest, and that's going to give us about 20 thousandths
To take off.
to take off the top of this block. Factory height on this block would be 9025. Yeah, we're going to end up 9.005 and 20 more here. So the block was right on what it was supposed to be by factory blueprint.
That's kind of a sanity check. By the math, we were going to need to take 20 thousandths off to be where we want to be, and that's exactly what it's reading.
Well, anyway, I've taken another reading between 1 and 3 cylinder, comparing it to my reading between 5 and 7, and it's virtually identical, which tells me that this deck is already parallel to the crankshaft.
So again, the way the block is fixtured on here, we are confident that we're going to be milling the surface perfectly parallel with the center line, but we did go ahead and throw a dial indicator up here to check what it is right now, and we'll just traverse this across. I didn't have it zeroed to start with there, but you can see again, it's staying pretty relatively even. I'm just going to slowly feed down on the Z-axis until I just hear it touch. Just heard it there. Yep. Yeah, so it's touching just a little bit back here. And we're going to mark that as 0 here. So basically what I usually do when I'm zero decking one is do however many cuts it takes to clean it. Here we'll probably take a 5 thou cut, and hopefully that cleans it. Then we can double check our height, set our value on the digital readout, and then cut to our final depth.
Sounds good.
I'm going to go down 5 thousandths. It's really a mess after that. I'd need you to clean it.
Maybe you need to clean it.
Cleaning guy's getting a lip on him.
Ah, I need new equipment.
How about a pizza party instead? Well, it's interesting. There's some erosion right there. Same thing on this cylinder. This one actually does look more like somebody had a Scotch-Brite pad, a little aggressive, or a whiz wheel, something.
Yeah, whizzed on it or something.
Did something.
It's interesting when you start surfacing a block and you can then see all of the things that you may or may not have picked up with a feeler gauge and a straight edge or even a dial indicator.
When I zeroed off on the deck, it was touching more over here than over here. So I wouldn't be surprised if we were off just a tiny bit. Anyway, now we have a good surface to work off of. I'm going to say we have 17 left to go. Yeah, we've got 17 there again. So with that being said, I'm going to hit Z here, put 0.017 and hit enter. Now when we get to 0 on the Z-axis there, that should be our final cut. So I think I'm just going to do another 5 thousandths cut. I'd rather sneak up on it and take our time here. So we'll take it down to 12 thousandths on the readout there and do another cut. A hair past 12, we might be about 11. Call it 11. So I'm just going to change that to 11. Let's take another 5. That'll take it to 6. To 6 right there. I'm going to say we're pretty much between 5 and 6. It's kind of an art to master using this gauge, honestly. We're right in that same range. Let's call it 5. Okay, so I went ahead, reset the DRO to read 5. I mean, we're right in the middle between 5 and 6 from what needs taken here to be at our final deck height. I'm going to take a 4 thousandths cut, and hopefully that'll leave me with 1 thousandth to do a finish cut, and we'll be done on this side. I like that finish. You can see see a rainbow in it. Yeah, I'm gonna call that 1 thou. Might even be slightly less than that. Right at 1. So we're gonna take a 1 thousandth finish cut. Remember, we were at 1 on the DRO on the last pass. Now we're going to 0. This should get us right at our 0, but I'd be happy if we were plus or minus 1 thou from there. But I am gonna slow the table feed down to hopefully make sure we have the nicest, a nice surface finish here, and we'll go from there. We might be between 0 and 1. So a little farther than I wanted, but yeah. I'm going to say we're between 0 and 1, which is going to put the piston between 4 thousandths and 5 thousandths in the hole, assuming the rest of our dimensions of our parts are exactly what they say they should be. So I'm happy with that. So now, with our fixture here, we can roll over to the other bank, and we know that we're going to be perpendicular to the opposite bank. And what we can do is not change the digital readout at all and run to that same 0 point, and it should put us at the exact same spot on our deck height. Obviously, we're going to check when we get close to make sure, but the machine has always been pretty reliable. And we're pretty good. We're on the opposite bank now. All right, so I'm getting about 22 thousandths. About 22 thou again. So let's cut it, shall we? So we actually started around 20 and a half. It's about time you show up for second shift.
Gotta eat sometime. I was hoping you'd already be done.
I accidentally took the numbers.
Oh no. We'll stamp our own numbers on there.
Okie dokie. Probably just gonna keep going, get down to like 5 and check, because the digital readout should be the same. Five, maybe slightly less than 5.
I was going to say, looking at it from here, you're slightly less than 5.
So kind of same thing between 4 and 5?
Yeah, I was going to say, I'm looking at from a little bit of an angle here, but I'd say with parallax and everything, you'd be under 5.
So when I'm going to take it down to 1,
Measure again.
we'll either do a 1/2 thou finish cut or a 1 thou finish
Okay,
cut.
that sounds like a plan. Looks to me like you're getting awful close.
I'm going to call it between 0 and 1 right now.
Yeah. Certainly not more than 1, but probably closer to a half.
I'm going to take a half, and we're going to see where that puts it. I kind of said if we were at our 0 plus or minus 1-ish, I'm happy. I
Yeah.
don't know, what's your opinion?
No, I agree.
That's what our 5 thou
Yeah,
is
that's
for.
what our 5 is for, is
Not just tolerance stack up on manufactured parts, but on our own work, too.
yeah, gives us a little wiggle room there. Just a good place to stop.
And like you were saying, everything heating up here and growing, it actually makes sense that if I put this at a half instead of 1,
That
you know,
you're going to
maybe
come out right. Well, it probably went from 70 degrees to 100 degrees.
yeah. Does your brain ever tell you that you're missing a step? Or your brain just doesn't ever? The problem is if you're dumb, but you're smart enough to know you're dumb, wouldn't it just be nicer to just be dumb?
Probably so. End result would be the same, but you don't have to worry about it.
You don't know that you're dumb, so you're fine. I f***ed that up.
Why?
Because I went to minus 0.0005.
So you're going too much?
Yeah. Too late now.
Yeah, you're into it now. You're committed now. That's why we have the 5.
Dang it. On the other side, I assumed if everything was right, the pistons would come out 4 to 5 in the hole. So maybe we'll get lucky and this side will be about the same.
Okay.
Dumb.
It happens.
As I did that, we're standing there talking about, wouldn't it be nice to just be dumb and not know it? Crap. So I actually overshot that cut by 1,000th from where I wanted to be. You go all that trouble to sneak up on it, and the last cut, you botch it by 1,000.
Yeah, you make a
Stupid mistake.
stupid mistake. It's an easy mistake even if you're concentrating, and instead we're in here talking about this, filming this, and make a mistake.
Yep.
So all the world can see. It happens.
What are we about? 1 plus past?
I was going to say, I can see a lot of 0 on the right-hand side of that needle.
Not a lot. Drama queen. I'm calling that we came out just past 1 too much, which puts it's going to put our piston right around 4 thousandths in the hole.
Yeah,
About
it's-
perfectly the same.
Yeah, it's looking like about 1/1000th less than you wanted to have. Well, that sucks, but that's the way it is. Realistically, that is undetectable in the way the engine's going to run.
I like doing these when we're checking them like we were with the deck height gauge,
Right.
and everything comes out like it should, and it gives you more confidence in the machine.
Right. And we've
You know.
had times that we got blocks in here that were so far off that we lost confidence in our machine. And we're like, man, this can't be right. But we go back and check and we find out, no, the machine is right.
Yeah. So it's nice when the digital readout, you come out the same on both sides, maybe with a little bit of expansion from
Yeah.
heat. It's nice when you get a nice surface finish and everything, and you put the deck height gauge in, and it's the same front to back,
top,
side
bottom.
to side.
Yeah.
So it's just nice when things come out good. It's just a problem when the dummy overshoots. You go to all that work to sneak up on it, and you overshoot the final cut by 1,000. But our goal usually when we're 0 decking, we go between 5 to 0.
Right.
We don't want the
We don't
pistons
want it
sticking
coming out of
out.
the top. We want to keep that quench. We don't want to be more than 5 in the hole. But that's why we do that 5/1000ths, is it gives us a little wiggle room.
Yeah.
We're not perfect.
Yeah.
We try to be perfect, but we're not perfect. We get it as good as we can.
Pistons hopefully come in on Monday.
Right.
Can do our balancing, can finish honing the block, and we're kind of ready to start
We're real
assembling
close to
things.
assembling.
So,
You probably need to kind of check those heads over, make sure they're okay.
but we're gonna move right along. I think it's coming out nice.
Yeah, I'm happy. And I've got something special for you when you get ready to start putting this together, so you'll see when you get ready to do your assembly.
I don't want to know what you bought. I think I have an idea.
Yeah, it'll make the difference between this being an ordinary motor and a spicy race motor.
Oh no, I know exactly what you did.